Hey everyone, and welcome. Today we are diving straight into one of the most fundamental and honestly one of the most fascinating relationships in all of microeconomics. We're going to completely demystify the mathematical dance between average product and marginal product. Now, I know these economic metrics can sometimes sound like a whole lot of jargon, but I promise you, by the end of this explainer, you're going to see this as a perfectly logical, highly visual story of how businesses actually operate. So get ready to look at production in a completely new way.
Here's a quick roadmap for today. We'll start by setting up the short-run production environment. Then we'll officially meet our main characters, average and marginal product. After that, we'll hit the core of the explainer, the 3 rules of production, followed by a visual breakdown of stages I and II. Finally, we'll venture into what economists call the stage 3 absurdity. Okay, let's dive into this.
Section 1. The short-run production setup. Establishing the environment.
Right, so to truly understand these metrics, we kind of need to set the stage first. We can't just throw numbers around in a vacuum, you know? It all starts with the production function. Now, please don't let the word function intimidate you. Just think of it like a recipe. It's a purely technological relationship that translates your physical inputs, things like machinery and human labor, directly into physical outputs, like the total number of widgets a factory can crank out in a day. It assumes we're using the best available technique, so no wasted resources. It's just the raw physical reality of making things.
Now, in economics, time is literally everything. And our explainer today focuses strictly on the short run. In the long run, a business can change, well, everything. They can build massive new factories, buy entirely new fleets of equipment, whatever they want. But in the short run, we're restricted. We have what we call fixed factors, like the physical size of our building or the number of machines we own, and we cannot change those right now. The only lever we can actually pull to increase production is manipulating our variable inputs, and that almost always just means hiring more labor. So keep that in the back of your mind. Fixed space, variable workers. Section 2. Meet average and marginal product. The main characters.
Okay, now that our factory floor is set up, let's meet our 2 main metrics. First up is the average product, or AP for short. This is basically your baseline. It's just the total output of the entire team divided by the number of workers you have on the floor. For example, if 10 workers produce 100 widgets, your average product is 10 widgets per worker. It gives us this really nice, broad, smoothed-out picture of how productive our labor force is on average.
And then we have our dynamic character, the marginal product, or MP. Now, I really want you to heavily stress the word additional in your mind here. The marginal product is the extra, incremental output generated by adding just one more worker to the mix. It's not about the whole team anymore. It's strictly about what worker number 11 brings to the table that literally wasn't there when you only had 10 workers. Marginal product is the active driving force on our factory floor.
Section 3. The 3 rules of production, the core relationship.
So this is the crucial part. This is where we see exactly how the marginal product actively interacts with and actually pulls the average product. There's a highly structured mathematical logic to this, captured in a brilliant rule of 3. Let's walk through it. Rule 1. When the marginal product is greater than the average product has to rise. Rule 2. When marginal product equals average product is completely constant and at its maximum. And Rule 3. When the marginal product is less than the average product starts falling. Honestly, the best way to think about this is like a school test score. Imagine the class average is currently an 80. If a brilliant new student joins the class and scores a 95 on the next test, that 95 is your marginal product. Because 95 is higher than the 80 average, what happens? They pull the entire class average up. But if a new student scores a 60, their score is below the average, so they inevitably drag the class average down. Marginal product behaves the exact same way. It acts like a magnet, constantly pulling the average product in its direction.
Section 4. Visualizing stage 1 and 2. Proving the math.
Let's move from that mathematical theory directly into some visual proof. Look closely at how clearly this graph maps our test score analogy. Trace that taller curve with your eyes. That's the marginal product, or MP curve. Notice how it physically sits above the average product, the AP curve, throughout all of stage 1. Because the new worker is constantly bringing in more output than the current average, the MP curve is actively pulling the AP curve upward. It pulls and pulls until they intersect right there at point A, which is the boundary line between stage 1 and stage 2. At point A, MP exactly equals AP, meaning the average has reached its absolute maximum limit. The source text actually summarizes this elegant relationship perfectly. It says, If an additional worker is to increase the average product of all workers, the MP of the additional worker must be greater than the AP of the existing workers. I mean, that is just the perfect logical explanation of the power of the additional worker, right? It's just unavoidable mathematical gravity.
Section 5. The Stage 3 Absurdity, where logic breaks down.
So we've seen the math work beautifully in the early stages, but what happens when we push the system too far? Well, this graph brilliantly illustrates the entire life cycle of our factory, mapping our 3 mathematical rules onto the 3 distinct stages of the law of variable proportions. In stage 1, the MP curve is above the AP curve, dragging it up. In stage 2, notice how the MP curve crosses below the AP curve. Suddenly, the newest workers are less productive than the average, so the AP curve starts to fall. But look at stage 3, all the way over to the right. The marginal product curve literally plummets through the bottom axis and goes negative.
Let's quickly summarize this with a handy cheat sheet. In stage 1, we have increasing returns. Our fixed resources are being better utilized, so both metrics are rising. In stage 2, diminishing returns kick in. The equipment is getting a bit crowded, so MP falls towards 0, which drags AP down from its peak, though both are still positive. Now, a rational producer will only ever operate in stage 2. Why? Because if you stop in stage 1, you're leaving unexploited potential on the table. Your average efficiency is literally still rising. But you absolutely must avoid stage 3, where MP becomes negative. Operating there is a state of total economic nonsense.
Before we wrap up, I really want you to lock this absolute rule into your memory. It is a crucial memory hook, whether you're taking a test or running a business. Marginal product can absolutely plunge below the line and become negative if you hire so many people that they're just bumping into each other and breaking machines. Your total output drops, making the marginal addition negative. However, average product is always positive as long as output is actually occurring. I mean, you can't have an average of less than 0 widgets produced, right? This is the defining contrast between the 2 metrics when your capital gets desperately overcrowded. I want to leave you with this final, provocative question straight from our source material. In stage 3, when marginal product is negative, total output is actually shrinking. So why on earth would a rational firm incur the expenditure of employing an additional worker if it directly results in a decrease in total output? The answer, of course, is that they wouldn't. Even if that extra worker offered to work for free, hiring them would literally cost the company output. It's a fascinating thought experiment, isn't it? And it perfectly highlights why understanding this dynamic dance between average and marginal product is so utterly essential. Thank you so much for joining me for this explainer, and keep exploring these incredible economic forces.